Good morning, everybody. Today's webinar is going to be about spring warm-up and changing grain conditions. So today's webinar on Wednesday, March 9th. So I'd like to welcome everybody that's joined us here today. We're going to talk about on how our equipment can help with the spring warm-up changes, whether you're doing natural air drying, whether you're doing aeration only and you just want to warm up the grain. Our controller can help with either one of those. Also, we will talk about some of the risks. Aeration obviously is very important throughout the spring warm-up. Obviously, as we go into the spring area and spring time frame, we have a lot of warm and moist air, obviously, that's starting to become surrounded around the grain bins, and obviously that air that can create condensation and the risks that go along with that. So it's very important that we have aeration of some kind, and what the steps to do on our controller and how our controller and our equipment can help automate that process for you and help manage that grain condition throughout the months that you're going to be storing it. So, again, I would like to welcome everyone that's joined us today. This is a recorded webinar, so if you guys need to refer back to it at any time, there will be a link on our website so that you can actually go in and access that from a YouTube channel that we have at AgriDry Support. And at the very end of the webinar today, we're going to open the phone line. So if you guys have any questions about the topics that we're talking about today, we want to make sure that hopefully we answer those questions at the very end. So let's go ahead and get started. And like I said, we'll go through it and we'll have Q&A afterwards. All right, so what we're going to cover today is the risks, the potential risks associated with limited or no aeration during those spring conditions. We've already talked about it. Obviously, if you have your grain cool down in the grain bin and you're going to be storing the grain now for a longer period of time throughout the spring and summer months, that it's very important to have some type of aeration or at least manage that grain temperature and or moisture throughout that entire time frame that you're going to be storing the grain. So we're going to talk about the risks associated if we don't have that aeration. We're also going to talk about, on our controller, the settings for the different modes. So we typically have customers each year that may need to do some finish of grain drying, meaning change of moisture throughout the spring months. So on how to set those different modes up. If the guys already have the moisture right where they want it and they just need to control the temperature, basically aeration, on how our controller can help with that. So we're going to talk about the different modes of what our capabilities are with our controller. We're also going to talk about the powered roof exhauster program, and this has been in our controller now, I believe, since 2009. Some of the older controllers may not have that, so if any of you guys have an older, what I call a 3-menu program, and you have powered roof exhausters on your grain bin, we have a program now that is very important usually to run throughout the spring and summer months to help keep that headspace cool down in the top of the grain bin. So we're going to talk about how our roof exhauster program works and how that can help with the associated risk, obviously, throughout the spring and summer months. And then we're going to talk about, lastly, the grain sensor selection and the alerts of what we can do with our communication package. It's very important, obviously, to keep an accurate average, especially if you're doing the aeration side only, temperature change, so that you have an accurate grain temperature average by selecting and deselecting sensors, and then have the alerts, if you have 80-link communication, to alert you if something is maybe starting to go out of condition or starting to warm up and track trends. So it's very important to have that set up if you'd like, and just another way to give you a heads up or help manage, like I said, that grain in the bin that's very valuable. So the spring mode tips, the very first few that we're going to talk about is the very first one is that we want to make sure that the outside weather conditions are consistently above freezing conditions before the controller settings are adjusted for spring. And I guess what I mean by that is, obviously, as we come out of those winter months and it starts to warm up, depending on where you're at and across the country, we may have a few warm days, but then the next week is back down below freezing and whatever else. So it's not going to hurt anything if we have a warm day or two throughout those first few weeks coming into the spring pattern, that you don't necessarily need to adjust those settings right off the bat on the controller, all right? It's just because you have a couple warm days here or there, yes, it's still important to check the grain and monitor the grain and monitor grain temperatures and whatever else, but to physically change the controller settings to go into a spring mode for temperature control or moisture control, wait until those conditions outside are consistently above freezing, above 32 degrees or 35 degrees. Get those consistent weeks to where we know that we're going to be out of those wintertime months, okay? Second, sample the grain if you need to. So if you guys are changing the grain moisture, if you guys have natural air drying bins and changing the grain moisture, if you were able to do any moisture change last fall, and now you don't maybe not necessarily know exactly how far that front moved through, or if you need to change any moisture whatsoever, you need to sample that grain just to make sure, see where that front is or see what the actual moisture is. And then that's going to obviously alert you or tell you of what mode you need to put the controller in. So we advise, and obviously we had a webinar about sampling grain here a while back, which is a recorded video as well, webinar that you guys can access. But whether it's through the sampler tubes towards the bottom of the bin, as well as take a sample towards the top of the bin to see exactly what that moisture is. And if there is some moisture that you need to take out, or if it picked up moisture, then we know exactly what mode to put it in, and we can help you out with those settings, either from here or any of our customer service reps or installers out in the field to help you set the controller for what you need to do. So it's very important, if you're changing the moisture, you know the possibility that there's a moisture change needed, that you find out what that moisture is so we know on how to set that moisture window up. And finally, you want to continually monitor all the grain temperatures throughout the bin. So if you have multiple cables in the bin tied to our controller, if you just have one, either way, you want to make sure that you monitor those temperatures from the bottom to the top and watch for trends. And obviously our controller can help you with that through a hot spotting feature on our controller, or no easier than the 80-link communication that we can set some alerts and help track that information as well. So there's many different ways to monitor it, but it's very important to always monitor those temperatures and and always make sure that they are holding stable of what you want to keep the grain at. So the key point, and there's several things, but one of the main key points to long-term grain quality, if you're going to be storing the grain into the spring and summer months, is we have to control the temperature and moisture of all the grain. All right, we have to be able to push that temperature or moisture front, whatever we're doing, from the bottom to the top. We can't stop it halfway up. We can't just turn the fans off if that temperature front or moisture front has only moved so far, because there's obviously issues that can occur as that grain starts to warm up or as those conditions change throughout the spring. So our controller can help you do that, and very important to do that. So the importance of aeration throughout the spring months is there's two major points. The first point is condensation, which condensation obviously is the risk of not equalizing that grain temperature closer to the ambient air temperature outside. So think of the easiest explanation that we usually give customers is think of a glass of water, ice cold water on a patio table in the summer. You have that condensation that forms on the outside of the glass. There's a temperature differential there. That same idea can occur in the grain bin, okay? And there's risk obviously associated with that. We can help with that risk so that you don't have those condensation issues throughout the entire bin. So that's the very first one, and it's very important to push that grain temperature front throughout the entire bin. Whenever you're changing a temperature front, we want to make sure that it pushes it all the way throughout the entire grain mass, and that's one of the ways that we can help, make sure that we don't have any condensation whatsoever. Moisture migration is another risk, and that is more associated if you don't run the fans at all through those springtime months. If you don't seal off the fan inlets and you actually have just a natural airflow, through your fan inlets, your roof vents, obviously if you don't seal any of those off, just the what I call the chimney effect, or the moisture migration, that warm temperature on the outside of the bin, as those temperatures increase outside in the headspace area above the grain, starts to heat up and that grain temperature is still very cold, you just have a natural airflow throughout those bins, and that can actually cause issues as well with some high moisture points to where the air can no longer carry so much moisture. We'll have a slide on that here a little bit later that actually shows a little more in detail. So those are the two main points that it's very important to aerate at some point throughout these spring months and gradually warm that temperature up or finish taking the moisture out of the grain. Whatever you need to do, there's several different ways, and we'll go through those modes here in a little bit. So condensation moisture, the temperature differentials of more than 10 degrees or more, obviously, can create potential condensation in the grain mass. That might be actually in the grain mass itself, somewhere located throughout from the bottom to the top. It could be condensation at the very top of the bin where that headspace is much more, much more different or higher than what the grain temperature is at the very top of the bin. There's different ways that condensation can occur. It starts at 10 degrees, and obviously as it increases from there, it's much more drastic as we go through. So those wide outside temperature swings can create condensation on the grain at the top and on the sidewalls of the bin. So if you pull grain out of the bin and you notice that you have some grain sticking to the sidewall of the bin, that's because of the condensation, that temperature differential. And to help eliminate that issue, it's by warming that grain up gradually and bringing that grain temperature much more closer to the outside air temperature. But then obviously if you have a crust of grain at the top, that's because of the temperature differential from the headspace to the average grain temperature at the top, physically inside the grain bin in that headspace temperature. So there's two different areas where it can cause condensation. So as that air temperature warms up, so let's say you have 35-degree grain temperature in the bin, and it's somewhat equalized, obviously, throughout the entire grain mass, and that outside air temperature starts to warm up in the springtime months. Let's say we have an average outside air temperature of 50 degrees, the potential for condensation is going to be at the top of that grain mass, all right? That headspace area that has no grain is going to heat up. Obviously, a bright, sunshiny day, that temperature in the headspace might be even more than 50 degrees if it has bright sunshine shining on the bin roof and heating up that headspace temperature. And then obviously can cause issues on that top layer of grain where that condensation just drifts right back off the roof and forms a layer of condensation moisture right on top of that grain mass at the top. And that's where that crusting issue can occur. So that's a perfect example. This is why we have to have that aeration throughout the spring months. Is why it's very important to eliminate those risks. Secondly, when changing the grain temperature, like I said before, as we warm that grain up little by little with our controller, and the easiest way to do it is obviously with our controller to take the guesswork out of it, because the biggest thing when we're trying to warm grain back up or change the temperature whatsoever, we don't want to screw up the moisture if you already have the moisture right where we want it. We don't want to, continually to shrink the grain on the bottom. We don't want to add too much moisture where it causes condensation on a temperature front throughout the entire bin. So as we go through these sit-ins here in a little bit, when we're changing the temperature of the grain, we ensure that the moisture of the air is still right around your target moisture so we don't screw up the moisture when we're trying to take temperature in or out of the grain, all right? But as we push that temperature front through, we gradually warm that temperature up throughout the entire bin. We want to make sure, and you can see that on your grain temperature sensors, and the controller will help you with that as well because it's averaging those temperatures and taking all those temperature sensors into effect, whatever ones you have selected, that it will make sure that average grain temperature from the bottom to the top gradually warms up to your target temperature setting. And we're able to gradually warm that up until your average grain temperature gets to the point to where you want to stop, or up to the point to where it's beneficial or safe to store that grain then throughout the spring and summer months. Okay, but if you start that temperature front and you don't push that temperature front throughout the entire bin, if you start that grain warm up on the bottom, but then you stop the fans or you don't allow the fans to continue to push that 45-degree air, you might say, to the top, we have potentially condensation somewhere wherever that temperature front stopped inside that grain bin. Okay, so if you have 45 degrees and 35 degrees wherever that layer is, and that temperature stays there long enough, now obviously just for a few hours, for a couple of days, it's not going to hurt anything, but if it stays there long enough with no more airflow whatsoever, then that's where the condensation can occur somewhere in the middle of the bin, has crusting, go to unload, and you have unloading issues and safety issues, obviously, that will go along with it. And that's something, obviously, that we want to avoid whatsoever from guys getting in the bins and trying to get grain movement again and the safety along with that. So it's just another way to ensure that you're going to have good quality and ensure the safety as you unload the grain out of the bin. So we talked about moisture migration. And the moisture migration, this is a springtime example, all right? So you see the warm air outside, all right, and it starts to come in throughout. And then, like I said, this is for no aeration at all. So if you didn't run the fans whatsoever, you didn't set the controller to run the fans to warm your grain gradually up or have no aeration whatsoever, as that outside temperature starts to warm up, it's pushing into the headspace, it's pushing in from your fan inlets at the bottom. That warm air rises and it pushes right back down, right in the center of the grain mass where it's, the airflow goes to. And that high moisture zone can occur on the very bottom of the grain bin right in the center, all right? And what that does is it drops so much moisture, then it has the crusting issues, and it plugs your sumps and causes issues with that as well. You also see it in the springtime moisture migration that it'll form along the sidewall as well because of that major differential of temperature from inside to outside, all right? So that grain will stick to the sidewall, and that's where the moisture migration with no aeration whatsoever will cause an issue too. So you see it two different areas, right at the very center typically, where you can, and on the sidewall if you don't run any airflow whatsoever to try to warm that grain up. You mix moisture migration, that drawing that I just showed you, you mix that with any fine content, all right? So if you have your fines maybe not evenly dispersed throughout the entire bin, and it's tightly compacted area where you can't get any airflow anyways, you mix that with the fine content, that's exactly what this producer had. You have a mound of fines and a core close to the bottom that's obviously not going to come out through the sump. You have to get in there to break that up. And you also see that grain sticking to the side of the bin. Those two examples from not aerating properly, the two major issues that can occur, all right? And like I said before, this is not only a quality issue, this is a safety issue, and this is what we want to avoid and help you guys avoid at any point. So a few more tips that we look for spring. Dry grain. A lot of guys think that okay, I have my moisture right where I want it, and it was cooled down throughout the winter months, I'm not going to have any issues. Well, dry grain can still deteriorate or go out of condition under incorrect circumstances. Goes back to that moisture migration or condensation. You can still have quality of the grain deteriorating if those are not looked at and not operated correctly with our controller to help monitor those conditions. All right, I'm not going to say always. All right, there's a few things obviously in the time frame on how long the grain's going to be stored inside the bin, and everything goes along with it. But like I said, there's customers that I've come across that they know that they had dry grain, and they pop that hatch open and they start unloading the grain, and they notice grain sprouting at the top layer because they had condensation or sumps plugged and whatever else, and it's because of those two examples that I talked about with condensation and moisture migration earlier. Like I said before, when changing that temperature front throughout the grain, allow that front to push all the way throughout the entire grain mass, and that controller will help you do that. All right, as long as you have the sensor selected that's in the grain, it'll monitor those temperatures, it'll average those, and that entire average has to get within the parameters of what you set up in the controller, and you'll gradually increase your target temperature setting on your controller to help you get that entire temperature front pushed through. So that's how we do it with our controller, and that's how we do it efficiently with our controller. Instead of just going out and turning your fans on 24 hours a day to try to warm up the grain, at that point, if you're running the fans 24 hours a day, you can start screwing up moisture and then obviously taking away the quality of what you want. So we can warm up the grain, we can do it efficiently, we can do it safely, and yet still keep that consistent moisture of what you had in the bin to begin with right where you want it. And then lastly, there's nothing more important than you doing a physical check. Obviously, our controller is a managing tool. All right, it's a very good managing tool. It's like I call it the owner of the company, Eli. He says it's like a hired man. You know, you tell it what to do, and it's going to do what it's supposed to do, but you keep continually checking on it. All right, and that's exactly how we treat our controller. It's there to help, and it will help, but at the same time, there's nothing more important than you looking, smelling, feeling the grain across the top layer of that bin. Go up and open that hatch. Maybe go and turn the fans on and go up and take a smell as you open that hatch. All right, make sure that your quality of the grain is still where you want it, because Just because you have our controller and reading temperatures and making sure that it's consistent throughout the entire bin doesn't mean that something's not going to go out of condition, all right? Doesn't mean that you may have some fine pockets or something, uneven airflow across the bin somewhere where it can go out of condition. So there's nothing more important. Set up a schedule to monitor your grain, maybe once a week or once every 2 weeks as you store that grain. You have a lot of value, a lot of money in those grain bins, all right? And it's very important, especially a market like now, that the option to lose any money whatsoever is very crucial, all right? Obviously, we don't want to lose any money. You guys don't want to lose any money throughout any type of year. But when the market is so much tighter at this point now, it hurts that bank so much more, all right, because the option to have a little bit of variability is really not there anymore. But either way, look at your grain, monitor it, all right? Climb the side of the grain bin and just physically open the hatch. Maybe jump in on the top. Like I said, safety again. I mean, we're all about safety as well. Make sure that if you do it, obviously you're not doing it. Obviously, when you're pulling a grain out, and maybe you have another person there to monitor or watch when you climb in the grain bin. But physically look at the grain. Feel it. Make sure it's not picking up any surface moisture on the actual kernels themselves at the top. So everything goes along with that to make sure that you're in good quality. All right, so let's get into settings. So settings on the controller, and this is where, like I said, the controller is there to help you automate this whole process of what you want to do or what you need to do, all right? So what I call storage mode is changing the temperature only. If you have the moisture throughout the entire grain mass right where you want it for a target moisture, and you just want to warm up the grain or control the temperature of the grain, that's what I call storage mode, okay? There's several different ways to go about what you need to do. This is a door chart. You guys may be very familiar if you have it on the inside of your door of your controller, but it basically tells you some general settings and pretty much, default settings of what you need to set the controller at. We obviously have, and this is a corn example, so usually on that sticker you'll have a corn example and a soybean example. If you have different grain types other than those two, your target moisture and whatever else will be probably a little bit different for whatever you have for a grain type. But realistically, the settings for what we're doing for storage is probably not going to change that much, if any, for different grain types. So as we go through, we have a drying section and a storage section. This is what we're going to be talking about today. Obviously, what we're looking at is not the winter storage. We've already done that here late last fall or going into winter. We're coming out of this range. Now we're going into the springtime, which is very consistent with what we use for the fall time setting. So if you look at it, we set up a min and max air temperature, all right? And then there's a target temperature setting that's very crucial. We control the temperature of the grain two different ways. First, we make sure that the outside air temperature has to be between the min and max before it can even operate the fans, all right? So the outside air temperature has to be between those two figures before it's even going to automate the fans. And then secondly, we go in and set the target temperature of what you want the average grain temperature to be, all right? Now that temperature, there's a plus and minus temperature, this 5 degrees, is added to and subtracted to your target. So in this case, we'd be shooting for a 40 to 50 degree range of temperature. So if you have your average grain temperature in the winter months set, let's say, at 35 degrees, we could bring that average of 35 degrees up to at least 40, because that'd be the bottom side of the window, and allow that grain temperature to get up to 40 degrees. If you want to increase a little more, then just keep increasing this target temperature gradually until you get the average temperature of what you want. So these are the settings that we would use in the springtime. And if you look, like I said, the major ones that we're changing out of the winter time storage is we're increasing the maximum air temperature up to 60 because we want to use a little warmer air. And then, like I said, we're going to average that grain temperature by setting that target temperature up a little higher too, and it gradually brings that temperature up throughout the grain bin about 5 to 10 degrees at a shot, and that's how we're able to prevent that condensation. So we're not putting really, really warm air on really cold grain, and vice versa, obviously, if we was taking it into the fall time. But that's how we're able to gradually bring that temperature up and consistently do it and efficiently do it to get that grain temperature where we want to be. So that's important. If you guys are then going to store into the summer months, then we need to increase it typically a little higher, all right? So then we set our maximum up to 70 and then increase that target temperature up to 55 degrees. So if you had the average grain temperature was then at 40 or 45, If we set a target at 55, then we'd be shooting for a 50 to 60 degree window. And so it would bring that average grain temperature up to at least 50 on the bottom side, and then hold that grain temperature within those parameters. So it's very important to gradually bring it up. Just don't go out and run your fans when it's 60 or 70 degrees if you have 35 degree grain temperature in the bin, because that's where the condensation occurs, especially if you don't push that temperature front all the way through, and you have those pockets of major temperatures differentials throughout the entire grain mass. So that's what you're going to use for settings-wise of the storage mode. Another way to look at it, all right, and just to explain a little farther, to be in storage mode, and this is how we're able to hold your moisture of the grain when we're trying to change the temperature. So you're going to go into moisture control settings, and these are going to be probably set exactly the same if you was already in a wintertime storage mode, all right? Because if you was already in winter storage, the current and the target's going to be exactly the same already. But if you're not, if you're ready to go into storage and you haven't set it up for storage mode, set your current moisture and your target moisture settings the same, and as soon as you do that, it puts the controller what I call storage mode for temperature control. You're going to widen out your plus and minus moisture, if you haven't already, to at least 2.0. So if a default, or if you use in a drying mode, that's usually set at 0.5. So make sure you're set at 2.0 on that. And then obviously that sets up the parameter of when the fans can run. There's several different things that have to happen. So when we're trying to add temperature back to grain, we ensure that the moisture of the air, based on the EMC calculation, with this example, that the EMC calculation has to either be between 17 and 13%, meaning 2 points is added to and subtracted to your 15. So that's where we're getting 13 to 17. If the moisture of the air is above 17 or below 13, it's not going to allow the fans to run. So that's how we're able to ensure your moisture doesn't change. You don't shrink the grain anymore on the bottom and lose money of the grain being below market moisture. We keep the moisture right where we want it, and then we go in and set your target temperature settings, all right? Min and max, like I said before, outside air temperature has to be between those two figures. So if it gets above 60 degrees, we don't allow the fans to run. So we gradually warm that temperature up and keep it so it doesn't warm it up any farther than 60 degrees, obviously, because we cut the fans out after that. And so, like I said, air temperature between 30 and 60, and then your target temperature for a springtime mode, you're going to set for 45 degrees with a plus or minus of 5 degrees. So we'd be shooting for a 40 to 50 degree range of what our temperature cable sensors average is going to be between. And then, like I said, if you store grain then longer into the summer, then we're going to bump up that target temperature range and the maximum air temperature range. So none of these settings would never change once you're in that mode. So hopefully that makes sense for what we're doing. There's a couple settings, obviously, that we have to change. But we can help you with those settings, all right? We have tech support team here in the office that do that every day, all day, all right? So if you have questions about a certain grain type or how to go into these storage mode settings, give us a call here in the office. Talk to your sales reps. Talk to your installers. Talk to your dealers. Some of our dealers that are dealers for our equipment can help you with these settings as well. So there's many different avenues to make sure that you have the controller set up properly for what you're doing. So that's storage mode, all right? Now, for the guys that are wanting to change the moisture of the grain, so if you need to do some drying in the spring or changing moisture, maybe adding some moisture back to grain, what to do. So then we look at the drying side. Now, typically in a drying form, we're going to run a fairly wide window, and when I talk about wide window, usually min and max. Now, the problem with that is we don't want to warm the grain up much higher than 60 degrees, because once we go over 60 degrees, the capabilities of insect activity and whatever else, especially if you're going to be storing for a long period of time, can occur for insect activity. Plus the storage life on a storage chart is much less, obviously, with a higher temperature. So to help cure or to help prevent the grain from going over a certain temperature when you're trying to remove moisture, add moisture back to it, we change the maximum air temperature setting. So instead of a 90-degree maximum, we'll actually change that to a 60-degree, all right? Kind of like exactly what we did for a storage mode. So when we're drying, we can set it up for a drying mode, whatever you're doing, whether you need to take moisture out of the grain or put moisture back into the grain. We can set the drying mode settings in the moisture control menu, but then we can control the grain temperature by having a stopping point when the outside air temperature gets above a certain temperature. So I typically say 60, depending on where you're at throughout the entire, country, and you need some fan run time. We can always bump that up a little bit, but that's how we help control the temperature of the grain by changing the maximum air temperature setting on that. Because the temperature control settings, like we use down here in the storage mode, those are not a control factor anymore. When we're changing the moisture, it uses these settings, but none of the temperature control settings. So we're mainly looking at the moisture settings. We don't care necessarily about the grain temperature. We do, and we can control it by that maximum air temperature setting. So that's where we can help control that. So as that EMC calculation, when we're changing the moisture of the grain, as that EMC calculation goes throughout the window, it's going to run your fans whenever it gets within this green block. Anything above or below, if the EMC calculation gets above or below, it's not going to run the fans. But at the same time, it also looks at that minimum and maximum air temperature setting, and the outside air temperature has to be between those two figures as well before it can run. So not only do we look at moisture window, like I said, we still use that min and max air temperature setting. So as you guys are unloading grain out of the bin, all right, you start having you got to start filling those contracts. You start pulling grain out of the bin, start hauling grain to wherever you take it for a market. Those temperature sensors on those temperature cables can start to be exposed, okay? Now, the problem with that is when you're trying to do aeration, all right, if you start pulling grain out of the bin, you have an inverted peak. It's no different than if you just corn the bin immediately. When you're trying to run the fans and have consistent airflow all the way across, the potential areas that the grain can go out of condition, is on the very high sides of the bin, where that grain is much higher than the center of the bin. So always monitor, and that's one of the reasons why we have one of those cables typically by the manhole, 3 to 4 feet off the sidewall, so we can monitor that grain temperature along those higher portions of the grain, all right? Because that is an area that the grain can go out of condition and like I said, have potential deterioration where it can occur. So that's why we continually monitor those temperature sensors there and make sure, because we know that the airflow is not going to be as great there as an area in the bin that's much more shorter or less grain mass that the air is going to shoot right through and direct it towards. So that's why we look at those temperature sensors as well and always monitor them. Now, if we have any grain sensors that start to become exposed, all right, so like I said before, if you're starting to pull grain out of the bin and those temperature sensors start to become exposed in the headspace temperature, you need to deselect those sensors, all right? So if you look at, this is one temperature cable, all right, and this is what you guys would see as well on the screen, on the controller itself. Sensors 1 through 6 is just one temperature cable alone. Sensor 1 is at the bottom, 6 is at the top, and everything in between. So you can notice all of his grain temperatures from the wintertime storage, his average is 36 degrees. That last sensor, you can see on a warm day like this, is 20 degrees higher than his average grain temperature, and we know that that sensor's out of the grain. You want to deselect that sensor, all right? You notice it does not have an X on it. If you deselect it, it still reads it, but it does not use it into the average, and that's very important when you're doing aeration controls so that it doesn't throw off your average when we're trying to control the temperature of the grain. So as you pull the grain out of the bin, or if you have any sensors that come exposed on those temperature cables, no matter how many temperature cables that you have, always track and make sure that any of them that are out of the grain are deselected. Another way to do this easily is on our communication package, on the 80-link communication. We can actually, if you don't know, if it's very close and you don't know exactly if that temperature sensor is in or out of the grain, you can graph it, and we can help you do that as well. It's a very quick process, but we can graph those top sensors on the temperature cables and compare those to the outside air temperature, and whatever ones follow the outside air temperature, we know that those are out of the grain mass because the grain sensor would never change that quickly. So that's how we can help manage that as well, or if you have the capability to do that in your 80-link communication, just another quick way that you can monitor that and track it as well. So deselect any sensors inside the grain mass. Now, if any of you guys have powered roof exhausters, this is when the powered roof exhauster program on our controller is very important to use. As that headspace temperature above the grain mass starts warming up and that grain temperature is still cooled down, we want to operate the roof exhausters only to help that airflow just in the headspace alone. So how do we do that? We have the roof exhausters tied in separately on control switches on our controller. and we can automate those processes or those roof exhausters by themselves just by monitoring those headspace temperatures. So when we have those temperature cables throughout the entire bin, and we know that one of the temperature sensors is out of the grain, we can designate that as a headspace temperature. And I'll show you here in a little bit how to do that. But we then can monitor the headspace temperature, and then obviously keep an accurate average of the grain temperature. And whenever the headspace temperature gets above a certain degree rise above your average grain temperature, it'll trigger the exhaust fans by themselves. Doesn't run the bottom fans, so we don't want to warm the grain up anymore on the bottom, obviously. We just want to run the roof exhausters by themselves and keep that air circulated up top so we don't have that roof drip, condensation drip back on that top layer of grain and have the condensation issue on the bottom, or on the top of the grain, okay? So we run them independently. Obviously, if you're using a drying mode, we run the roof exhausters just the same as a top fan, okay? But this program piggybacks over the storage mode or the natural air drying settings, okay? So if you have power roof exhausters, it will, like I said, piggyback over the other program, and if the headspace gets hotter than the grain temperature, it'll run them just by themselves and takes that risk of condensation away. Takes that risk of bins that have that top layer where that roof drip created so much condensation, crust on top. Obviously, that prevents airflow going through, and obviously it can plug up sumps and safety and quality concerns, obviously, as you go through. This is what we can avoid if you have power roof exhausters on those bins. So how do we set the power roof exhauster program up? Now, this is a screenshot of our 80-link communication. And this 80-link communication is the reason I put it on here is because we can see all the settings on one screen, unlike showing a bunch of screens throughout our controller. But our controller screen would be no different. You just have a couple menus that you need to go into. But the first thing to do, set it up if you have power roof exhausters, is number one, set your min and max, just like we do with our average, with our temperature control settings for storage mode or natural air drying mode. All right, so that's still going to come in play. You still want to control the temperature of when the fans are turning on and off. That's number one. Secondly, you're going to set on how many exhaust fan stages that you need to match the switches that you have on the front of our controller. So let's say in this example, you see the fan stages at 2, meaning 2 switches on our controller, and out of that total, there's 1 roof exhauster. So that would mean that I have 1 roof exhauster controlled with our controller and 1 bottom fan controlled with our controller. All right, so a lot of this is already set up from the factory, but if it's not, maybe you add a roof exhauster, maybe the controller settings are still set at default settings. This is how we choose on how to run it. As soon as you choose a roof exhauster stages to at least 1, then the next important one is set the grain sensors. So the sensor count is the total number of sensors that we're reading into the controller. So if you have just 1 cable, it'd be 6 sensors total. We set the grain sensors at 1 less. So it designates that last sensor at the top of the cable, at the top of the bin, sensor number 6, as the headspace temperature. Okay, and then that's the sensor then that we compare to your average grain temperature, and that's how then it controls the settings. So those are the settings in the bin setup menu, whether you're on the controller setting or on 80-link communication, that has to be set to control the roof exhauster. If you have 24 sensors total, let's say the maximum that you're controlling into the controller, you would have sensor count 24 and then grain sensors to 23. Okay, and then that last sensor then would be used as the headspace. So this is what it looks like for those settings that we just went in actually on the controller. You notice all the sensors have a G in front of them except that last sensor, sensor number 6, has an H. H stands for headspace. All the other sensors stand for grain sensors. So it's going to average all 5 of those sensors, grain sensors, as the average here for grain, but then it looks at that headspace temperature, and then that's what it compares to with your average grain temperature. Have an X beside that, and it will use that sensor as control. And then in the exhaust fan control menu, this is where we want to obviously turn it on. And then we usually use the trip degrees, and you can set this at whatever you want. These are just the default settings. This is a good temperature setting, default settings of what I usually use for all of our customers. But the grain temperature trip differential right now is 20 degrees. So whenever that headspace gets to 20 degrees more than the average grain temperature, run the roof exhauster by themselves and cool that headspace temperature down. And it's going to run the roof exhausters until that headspace temperature gets back within 5 degrees of your average grain temperature, or 5 degrees within the outside air temperature, whatever one it hits first. And there's a minimum run time and an exhaust maximum run time. So both of those are set at 30 minutes as well. So these are good default settings that you should be using for your exhaust fan control menu. Okay, and that's how we control those powered roof exhausters for what you're doing. So then on the 80-link communication side, to help monitor and use that for alerts, we have 2 different ways that you can receive alerts through email or text message, and it's a very handy way to help track trends. Have the controller track that for you and just give you a heads up that says, hey, your average grain temperature is starting to increase, or your individual temperature sensors are starting to increase. You can track trends. So the first alert that you can set up, and these are what I call the threshold alerts tab on your 80-link communication. But you can track your average grain temperature. So if your average grain temperature, let's say, was 45 or 50 degrees in the spring months, and your average temperature then increased to 55, it would throw you an alert via email or text message, whatever you have in the filled out boxes above, and it would say, hey, your average grain temperature got within 55 degrees. There's possibly it's starting to warm up for whatever reason. It'd probably be a good idea to go look or see what your grain temperatures are doing. Maybe one of the sensors out of the grain is really throwing that average off, so you need to deselect some sensors. Maybe one of the sensors is actually increasing enough that it's increasing that entire average. So you can set a high and what I call a high, so you can look for trends. So if it hits 55 degrees, send you an alert. If it continues to warm up and hits 65 degrees, send you another alert that says, hey, we're seeing this trend that's starting to increase. Something's going on. We really need to monitor, really need to go check that controller, check the grain, check the temperature cables, and show you to do that. So that's a good way to use the 80-link communication, the alert system built into it, just to help monitor and maintain that quality in the bin. So that's the average grain temperature alert. Then you can go in and do individual grain sensors alert. So let's say you had 6 sensors. Let's say you had 24 sensors max. Whatever sensors you have, you can go in individually and do the same thing. So if an individual temperature sensor increased by itself, it would throw you in the same alert. Now, depending on how many alerts you want to get, obviously is on how many alerts you want to set up. But it's there to use if you want a good managing tool and a managing way to be able to help maintain that quality of the grain. So you can do the same with a high and a high. You can track those trends on certain temperatures, and a lot of guys like that because it alerts them before that grain continues to go out of condition, or alerts them enough that says, hey, there's something going on and I need to do something before that grain gets much higher of a temperature that's uncontrollable. Okay, so it's several different ways that you can use the 80-link communication. So we talked a lot of information about springtime warm-up, why it's important to have aeration, why it's important to change the controller settings for your different modes that you're doing, have that uniform airflow, get that temperature front pushed from the bottom to the top, all right, when we're trying to change the temperature front. If you have moisture in the grain that you need to take out or add, set it up for a moisture control menu and mode so that you can take moisture in or out of the grain, but yet still keep a stable temperature in the grain mass as well. Have that controller help you with that. That's what the controller is there for. That's how you get the return on investment for our equipment. All right, run those fans efficiently, run them at the right time so we don't screw up the moisture of the grain when we're trying to increase the temperature of the grain. Gradually take that temperature into the grain bin so you don't have the condensation with really warm air and really cold grain, and allow that grain temperature to warm up gradually and get it to a stable temperature compared to the outside air temperature. So many different things that we talked about and how our controller can help you with that, and then obviously tied into the communication program as well for what you're doing to help manage that as well. So that's going to conclude the webinar that we talked about today. Obviously, we talked a lot about spring conditions and how our controller can help out with what you're doing. We still do have discounts available up to March 15th is when our discount structure at this time ends. So if you guys want to take advantage of any of that, contact your local dealer, an AgriDry dealer. Our dealer list is on our website at AgriDryLLC.com. You can find that. You can talk to any one of our sales reps or service reps out in the field if you have their contact information, which is also on our website. Don't hesitate to call in the office here if you have any questions as well. Our toll-free number is 855-AgriDry. Another phone number that you can contact is 419-459-4399. So allow us to help you with whether it's settings, making sure that the controller is set up properly, questions on what to do, when to do it, stuff that we talked about today. We can help you out with that as you go through storing that grain for possibly long periods of time throughout the spring and summer months. So hopefully I answered a lot of questions. I'm going to go ahead and open the phone lines here, so if you guys have any questions of what we just talked about, don't hesitate to ask them. I'll let you know when the phone lines are open, and then we'll have it open here for a little bit. So hang on a second, and I'll open the phone line. All right, guys, I have the phone lines open, so if you still hear me, that's great. If you have any questions, don't hesitate to ask them. Go ahead and ask them. I'm going to be on the line here for a little bit and hopefully answer any questions that you have. So if anybody has any questions, go ahead.
Yeah, quick question. I missed the first part of your get-together, but I wanted to know about the hotspot. If you covered it, I'll quit talking right now. Did you cover the hotspots?
I did not, all right, and thank you for bringing that up. So the hotspotting feature is...
Let me ask you a quick question first. What I did is everything that you said with the hotspot turned on, and the hotspot kept recognizing itself as being a hotspot. It ran the temperature right up to the max temperature right off the bat when I really didn't want it to go there so soon. Then I had a hard time the rest of the weeks, spring leading into summer, to get the temperatures back down to where I wanted them. My thinking is maybe I should leave the hotspot off.
Well, there's two things, and do you know on your situation, do you know of what sensor maybe was triggering it as a hotspot? I know it usually shows it on the display. Maybe was it one of those temperature sensors that could have been closed or possibly out of the grain that was picking up headspace temperature, not actually grain temperature? Do you know if that was maybe the issue?
I had none of them out, of the grain I was reading because I already canceled them. But I can't tell you which one it was. It was last year, so I don't remember. Okay. Well,
there's two different ways, and whenever the hotspot, if it's turned on, the hotspot feature is turned on our controller, it monitors all those grain temperature sensors that's selected, obviously, with an X. That being said, it could be two things. First of all, if there's any sensors that's out of the grain at the top, obviously, if it picks up headspace temperature, it recognizes it as a hotspot and then turns the fans on, obviously, when it shouldn't be. So that's number one. Second of all, just the natural airflow throughout the bins, kind of like when we talked about the moisture migration, just the temperature flow, gradual temperature flow throughout the grain bins. If you don't seal the fan inlets off, and a lot of guys don't, obviously. I mean, I'm not saying you have to, but obviously that natural chimney effect. So that number one sensor that's close to the floor of the grain bin, as that natural airflow goes in throughout those inlets of the fans, and obviously if you have roof vents at the top, you have that natural chimney effect. And that number one sensor a lot of times being very close to the floor, because we like it that close to the floor to pick up the CEMC value, if it sees a temperature rise on that one just from the natural airflow, sometimes we have the sensors deselected on the number one sensor as well if we're seeing a temperature rise just from the natural airflow. So the biggest thing I guess I tell guys when to run hot spotting, it's there that you can turn on at any point, but hot spotting I tell guys to turn it on when you have high moisture grain and high temperature in the grain. If you have the moisture closer to your target of what you want, and you have the temperature of the grain cool down, as long as you're monitoring temperatures, whether it's right from the controller screen itself or through the AD-Link communication, a lot of times I'll tell the guys to turn hot spotting off just because you do have to monitor those temperature sensors much more and really track of which ones are picking up a temperature rise or possibly as those temperatures are coming out of the grain as well. So.
Okay, yeah, I understand what you're saying. Thank you.
You bet. Any other questions while we're here on the line?
Yeah, I have a question.
Yep. Anybody, go ahead.
So the temperature cables that are in the bins, is there any way the bin is pretty full? Sorry, the bin is really full actually. So the grain is really high up on the cables. But is there any way to tell when that top moisture sensor where it's located? I can't tell if it's out of the grain or if the grain is that warm at the top or what.
All right, so to physically see it on the temperature cable, it can be seen. It's sometimes hard to see, especially when there's dust in the cable and whatever else. The physical temperature sensors inside those cables are no more than a solder joint, and they're usually obviously interwoven in between those other wires that's in the cable. So to physically tell you where that sensor's at, because every grain bin height obviously is different and cut a little bit differently, so to tell you exactly where that sensor's at is going to be pretty hard to do. The easiest way, probably in your case, to figure out if the grain sensor is in or out of the grain is just and you can physically, if you have any question at any point, probably the easiest way to do it is just go ahead and deselect the sensor. So that top sensor, which would be number 6 sensor, deselect that sensor until you can watch it. Whether you watch it physically on the controller on a bright sunshiny day and the temperature warms up, or from the 80-link communication. But if you see any one of the temperature sensors, especially if you don't have any airflow closer to the top of the bin, if you see that any one of those temperature sensors is changing temperature rapidly, meaning kind of going up and down pretty drastically, quite a bit, kind of following the outside air temperature, then you know that it's out of the grain.
Gotcha.
We can, if you have 80-link communication, we can actually graph that, so you don't have to actually physically be there, meaning we could graph the number 6 sensor and the outside air temperature and see if it follows or see if it kind of tracks the outside air temperature, and we can, within a couple minutes, we know if it's in or out of the grain. If you have 80-link communication, we can show you on how to do that while you're online. But if you have any question, if you see that one's warmer, let's say you go out in the morning, let's say it looks fairly cool, but by the middle of the day, a bright sunshiny day, that temperature is increased, 10 degrees or 15 degrees or more, then the grain temperature itself would not change that rapidly, okay? So anytime that you see a drastic change throughout the entire day, from day to day, those are definitely, it's either close enough to the top of the grain where it's changing temperature quickly or out of the grain.
Yeah, makes sense. Thanks.
Okay. I think I heard another guy maybe ask a question. Go ahead.
Yeah, I have a question about monitoring that headspace. I think I've got 24 cables or sensors in the bin, and I checked them all on because that headspace is getting about 15 to 20 degrees warmer than the grain. We've had some 70-degree days. And I'm just wondering if I'm doing that right. Can I use those fans to kind of control that headspace a little bit, or is that not the way to do it?
So you have powered roof exhausters at the top of the bin, or do you only have bottom fans?
No, I do not have roof exhausters.
You do not have roof exhausters. Okay. The easiest way, all right, so to monitor headspace or to basically separate those temperature sensors from grain sensors to headspace temperature is only going to be important for the roof exhauster program, okay? So that being said, I guess the easiest way probably for you is make sure if you're getting some warm days, depending on where your average grain temperature is at this point, I don't know what that is. I don't know if it's still a 35 or 40 degree average or whatever you're doing. But what I would do is if you still have some cooler grain in the bin, I would gradually warm that grain temperature up if you haven't already, just by going through the storage mode settings of what we talked about, meaning gradually increase your target temperature setting from 45, from maybe 35 to 45, and then maybe even going into summer, maybe even up to 55. So you gradually warm that temperature up. Now, since you don't have any powered roof exhausters on the bin, it's going to be very hard to control just the headspace temperature alone, okay? Because if we try to use those bottom fans to try to cool the, to try to control the headspace, you're going to be changing the grain temperature at the bottom as well, okay? So what I would recommend for you is gradually warm that temperature up of the grain if you haven't already. Get it to an average grain temperature in the springtime months like now. I'm not sure exactly where you're located, but 45 degrees. If you go into the summer, I would warm it up to 55 degrees and hold that temperature, and the controller will hold that temperature for you. If there's any sensors that's out of the grain that is actually picking up headspace temperature, not designated as a headspace temperature, but actually picking up just the headspace temperature, it's much more warmer than the grain temperatures, deselect any of those sensors so it keeps an accurate average, And the biggest thing that I would tell for you is probably set up a schedule and watch. Make sure that you don't have the condensation at the top. If you store the grain then for, throughout the summer months for a longer period of time, even after you get the average grain temperature to 55 degrees, and maybe you see some condensation potentially forming, it's probably not going to hurt to run your bottom fans a little bit to help control that airflow, just to have some aeration throughout that bin a little bit to help control that for as you store that grain throughout those summer months. Unfortunately, without that power growth exhauster on top of the bin, we're not able just to move the Headspace by itself. You're going to be moving the grain temperature from the bottom to the top.
Okay, thank you.
You bet.
No, I sure didn't. I listened to it on the radio, and I thought it'd be...
Anybody else have any questions of what we've talked about that I can answer here while we're on the line?
I thought we might win by 15 because I watched them play the first time, but I don't know. You never know. I guess they're playing good. If they can keep playing good, but I don't know.
Okay, well,
I think
that might be getting a little interference there, maybe from another conversation. Does anybody else have any other questions?
Yeah, I guess I never looked. I was just looking last night, at the seed points. And
guys, I appreciate you coming on today. I definitely, like I said, this is recorded, so you can refer back to it any time. And like I said, don't hesitate to call us. We're here to help you guys, our dealers, our service reps out in the field, to get you the answers that you need as well. So don't hesitate to contact anybody, and as well as us here in the office if you need.
Well,
like I said again, thanks again for joining us, and look for upcoming webinars that we'll be putting on at a later date as well in the future. So thanks again, and everybody have a great day and a safe day. Thank you.
I don't know what they were last night.